Okay, so using data. So in this lesson, we will look at the following. And by the end of it, students should be able to produce and select data. So we've the two types of data, qualitatively and quantitatively, or qualitative data and quantitative data. Critically analyze data to identify patterns and relationships, identify anomalous observations, and draw and justify conclusions. So if we think about this word data, like what do we mean by data? So data is big business nowadays, and we are surrounded by data all the time, and we are all the time analyzing data, and we are all the time generating data as well. So if we think about just taking into account the last lesson that we looked at and the last practical that we done, where we designed an experiment to see what impact adding salt to water had in relation to the boiling point of water. So when we were doing that, we were gathering data, so we were generating data. And what are some of the kind of data? What are some of the data that we generated? What kind of data did we generate? So if we think about this, and this is the way you should think about data from now on. So these are the types of data that we can generate. So for example, when we got the mass of salt to put into the beaker, we generated data mass, okay, and the unit of mass is the gram. So we used a balance to get the mass of salt, and then we recorded that data, for example, in our template. So an example of a data point then would be mass. Okay, it's in grams, and that specific data that was generated was 50 grams. And what kind of data is that? So generally, you have two types of data. You have what's known as quantitative data, okay, and then you have qualitative data. So quantitative data relates to quantities, so the quantity of something. So for example, if we want to quantify it, or we want to quantify something, we're going to generally use a number. So for example, if we take 50 grams, this is an example of quantity or quantitative data. How do we generate? So generally there's different ways of generating data, or what do we use to generate data? So for example, when we took the measurement of mass, we used an instrument called the mass balance to generate this piece of data that we used in our experiment. And what can we kind of, like when we take data, we can actually draw conclusions from it, or we can make observations. So what does the data point 50 grams tell us? It tells us the mass of a thing. So in our specific example, it told us the mass of the mass of salt that we wanted to add to the water that we were measured. Again, if we think about another type of data, or another, we have temperature. So temperature is measured in degrees Celsius. So an example of a data point for temperature is 100 degrees Celsius. And we know that that's the boiling point of water, the point at which water turns a liquid into a gas. What type of data is this? Again, it's data in number form. Okay, it's represented a quantity. So therefore it's what's known as quantitative data. How do we generate this piece of data? Well, we used a graduated cylinder. We poured the water, for example, into the graduated cylinder. We looked for this meniscus, and we measured the volume of water off the cylinder, and therefore we used a graduated cylinder to generate this particular piece of data. That's if we're measuring volume. But in relation to temperature, we used a thermometer. So we took a thermometer like this, okay, and similar to what we do with a graduated cylinder, we use a thermometer and we look at how far the liquid in the thermometer has risen up, and then we read off the value that's on the thermometer. So for example, when water reached, without any salt, started to boil, we noticed that the temperature was 100 degrees Celsius. So we generated that data using a thermometer. And what can we do with that particular piece of data? Well, we can use it to measure the temperature of things. So for example, how hot or how cold an object or something is. In this case, we use it to measure the temperature of water. So we can use this data to make an observation or to draw a conclusion. Okay, so we can say that, for example, when the temperature is at 100 degrees, the water was boiling, there was bubbles being generated. There were the observations that we made. But also as well, we can say that, you know, the water at that point would have been very hot in comparison. If we had measured the temperature before we started to boil the water, it probably would have been at room temperature. Okay, so it would have been at a different, like it would have been a different data point that would have been generated if you recorded the temperature at that point. So again, volume is another example. We measure volume in mils. We use 500 mils of water. What type of data is that? It's quantitative. Why is it quantitative? Because it's in number form. We use the graduated cylinder to generate it. And what does this quantity of volume tell us about something? It tells us how much, or the volume of a particular liquid that is actually present, or that we've measured out. And again, we have other types of data then. So qualitative data is generally data that's in word form. So for example, when you're using a Bunsen burner, when you stop using the Bunsen burner, you have to change the amount of oxygen that's going into the Bunsen burner so that the color of the flame changes. So it changes to a yellow color. So again, we can make an observation and we can see that there's a yellow flame. And we can record that, and that observation is, again, we're generating data using the brain or the eye, and that's what's known as qualitative data. So qualitative describes a quality of something. And what kind of conclusions can we draw from that? Well, when we see a yellow flame, we can see that it's more visible, so therefore the Bunsen burner is in a safer state, so somebody's not likely to be burned from it. That's the kind of conclusion or observation that we can draw from the data. So again, we have quantitative, anything that's in number form, any kind of data that we generate that's going to be in a number form is going to be in quantitative data. If I do a survey and I ask people their age, they're going to give me a number. That is an example of a quantity or quantitative data. It's the quantity of time in years, for example, that the person has been alive on the earth. If I was to say, for example, I was to ask you to stand at the side of the road and record the color of each car that passed by in a 15-minute period, you're going to generate data which is going to be in word form, and it's going to be the colors of the cars. So for example, yellow, blue, green, whatever. So they're the two types of data. You've quantitative data and qualitative data. These are just some examples of how we generate and how we can use data to draw conclusions. So we can do all kinds of things with data, and it's like you're doing it all the time, but it's just to kind of bring language around that and to be able to be more conscious of what you do, because that, again, this is what science is all about. The kind of bedrock, if you like, in science is being able to make observations, generate data, and then analyze the data and come up with some kind of conclusion in relation to the data that you've analyzed. So what can we do with data? Well, we can analyze it, we can identify patterns, we can notice relationships, we can identify anomalies, so things that don't just look right, so data kind of points that stick out, and we can draw and justify conclusions. So again, like this might seem like, you know, kind of alien language, but it's not. We do this all the time. So if we look here, so again, we have data in front of us. What kind of data? Well, we have quantitative data, so we're measuring temperature and mass, and then we also have qualitative data up here in relation to days of the week. So we can see here that we have different days of the week. We took different measurements. So for example, temperature, or we took mass. Now, I'm not applying this to anything in particular, but we could look at something like, you know, like different days of the week. This could be the temperature of a room, for example, as we measure it during each day of the week. If we take this like mass, okay, so this could be something like if we were to measure, so for example, over a week that there's been some rain, we can, and let's say if we were to measure how much water has soaked into a piece of soil by putting a piece of soil in a container and then measuring it each day, we can see that we could generate data like this. But again, this data could apply to anything. So if we take this data, what can we do with it? Well, we can analyze it. So we can actually look at the data and see, have a look at it and what's happening to the data. We can identify patterns. So if we have a look at this, so temperature, we can see, roughly speaking, as we go through the week, okay, in this case, the temperature seems to be getting hotter, okay, and the temperature is increasing each day. Now we have this anomaly here, something that doesn't look quite right. Okay, there's a dramatic change. So this is an example of what's known as an anomaly. But we can see that the pattern basically is that as you go from Monday to Saturday, the temperature is actually it's increasingly getting hotter and hotter and hotter. Again, we can look at the mass. Again, we can see that as you go from Monday to Saturday, the mass is actually increasing, okay, except for Wednesday. Okay, there's this dramatic change in the mass. Okay, so that's when we talk about noticing patterns. These are some kind of patterns that we can notice in this particular data set. We can notice relationships as well. So we can see the relationship between the day of the week and the temperature, or the day of the week and the mass that's measured. And then what we can do is we can take this data and we can we can make justifications or come up with conclusions from the data. Now, we can identify anomalies. So we can see here that if we look at this, we can see here that straight away, this data point here, it just stands out. So that can indicate that there was something wrong. So on that particular day, whoever measured that temperature, maybe they incorrectly read the thermometer. Maybe they didn't even measure the temperature and they just put in a random number. There could be any number of reasons here for this, and the same with the mass as well. So this here is an example of an anomaly. Okay, so it's something that's kind of standing out. So that kind of indicates there's something kind of going on here. Okay, on the Wednesday something happened, something went wrong. This doesn't look quite right. So therefore it's an anomaly in relation to all of the other data points. So it stands out. So that's what we mean by when we're talking about an anomaly. That's what we mean. Now, when we talk about like just drawn, like coming up with conclusions or justifying conclusions, what we can say is that as we go from Monday, as we move through the week, the temperature increases. That's a conclusion. Okay, as we move through from Monday to Saturday, the mass increases. Okay, so that's a kind of conclusion that we can come up with from the data points that we look at. So that's what we mean by, like, when we're talking about analyzing data, identifying patterns, noticing relationships, identifying anomalies, and drawing and justifying conclusions in relation to data. That's what we're talking about. So what we can do then is we can take data and we can present it in different ways so that we can analyze it and so that we can notice any patterns and we can look at relationships and we can identify anomalies and draw conclusions as well. So I'm going to look at some different ways that we can take data and we can put it in a way that we can analyze it a little bit better. So if we have a look at this, so this is data, and this data is in the form of a bar chart. So this is a really good way to take data and to arrange it so that you can analyze it. So I'll just take a few minutes, have a look at the data set, okay, and see, and so maybe pause the video and just analyze it. So have a look at it. So what is the data about? What can you notice? Can you identify any patterns? Is there any kind of relationships? Do you notice any anomalies? And can you draw and justify any conclusions from this particular data set? Okay. So if we have a look at it, so what is the data about? So again, when we have a graph like this, it's always a good idea to have a heading on the graph. So this is aluminium collected during the week. So maybe this is a person, for example, that runs a scrapyard and they're taking note of the amount of aluminium that is collected in a week, okay, in a week period. And what they've done is they've taken 3 days, so Monday, Wednesday, and Friday. So these are the days of collection, and they've measured in mass, like in kilograms, how much aluminium was collected each day. So we can see like one pattern that we can see. So what's happening as we move through the week? The amount of aluminium being collected is being reduced. Okay, it's reducing, and it's actually reducing dramatically. Monday seems to be the day that the most aluminium comes in. Okay, so Monday is the day when we have a lot of aluminium being collected. So we can see here that we have four. If we read the graph, so Monday, we can see that on a Monday you get 4 kgs of aluminium being collected. We can see that that drops off to the middle of the week. To a Wednesday, for example, that drops down to 1 kg. And then we can see that on a Friday it starts to kind of creep up again up to about 2 kgs. So that's kind of patterns that we can notice here in this. So again, the relationships then is like, how do the days of the week relate to the amount of aluminium being collected? We can see that there seems to be a relationship that, between like the start of the week and the end of the week, that seems to be when the most aluminium is collected, whereas in the middle of the week, that seems to be where the least amount of aluminium is collected. Can we identify any anomalies? So we don't know, like it seems unusual that we get a huge amount of aluminium on a Monday, and then we get like nearly less than half of that on the Friday. So that might be an anomaly. We'd have to kind of investigate it a little bit further. So draw and justify any conclusions. So what are some of the conclusions that we can come up with? Well, we can say that Monday is the best day in the week for collecting the aluminium. That's when the most amount of aluminium is going to come in. Wednesday seems to be the least busy time in relation to the coming in of collecting of aluminium, and then Friday kind of things pick up again as well. So if we're running a business, for example, and we wanted to identify the busiest times in the week in relation to aluminium collection, well, Monday is going to be the busiest time, whereas Wednesday is not going to be that busy. So again, you can look at this data and you can notice all different types of patterns. You can notice relationships, you can identify any anomalies, and you can draw and justify lots of different types of conclusions like what we've talked about. So again, another way to analyze data is, instead of putting it as a bar chart, you can actually put it in as a line graph. Okay, so this is a line graph. So along this horizontal is the x-axis, and along the vertical is the y-axis. So again, it's always a good idea to have a heading. It tells you what the data is about. So this is the temperature of heated water. Okay, so we can see along the bottom we have time. Okay, so it goes from 0, so it's in minutes. So notice the way that when you're labeling your axis, it's always good to put in what you're labeling, and it's also a good idea to put in the units that you're using to measure as well. And the same has been done here. So we have heating time in minutes, and then we have water temperature in degrees Celsius. So what we can see is that as we heat the water, the temperature of the water increases over time. And we can actually see that there's like a linear kind of relationship between this here. So the more time we spend heating the water, the hotter the water starts to get. So it starts to increase. So we can see here, so what patterns can we see? So for every minute, roughly, like, so it takes, in this case, like the pattern that we can see is that as time goes by, the water starts to get hotter. So that's a relationship between time and the heating of the water. And what we can see is it takes about, in this case, whatever way they're heating the water, it takes about 5 minutes for it to go from roughly about 50 degrees up to 100 degrees. So if there's a 50-degree increase in temperature across this. So can we justify or come up with any kind of conclusions from that? What we can see is, like, one conclusion we can see is that it takes about, so for this way of heating water, it takes about 5 minutes for an increase of 50 degrees Celsius in the temperature. So again, this is using a line graph, and this is a way that we can identify, and we can come up with different ways at analyzing the data. Okay, another good way to analyze data is to use a pie chart. So again, this is a pie chart. So again, it's always a good idea to have, so we can see straight away there's a heading here. So it talks about pet ownership. And then down along the side here, we have different types of pets. Okay, so different types of pets that we have. Okay, so we have dogs, cats, fish, rabbits, and rodents. and each of these sections of the pie are representative of the percentage of each of the types of pet owners own. So we can see here straight away, just looking at the data, that like the pattern and relationship we can see is that it seems to be dogs are the most popular pets in relation to this group that was surveyed. The next is cats, okay, followed by fish, followed by rabbits, and then the least popular is rodents. Okay, so these are the patterns, relationships, and draw and justify any conclusions. So what conclusions can we come up from this? Well, the most popular pet in relation to the pet ownership is dogs, and the least popular are rodents. So again, this is taking a data set and analysing it, noticing patterns, noticing relationships, and drawing conclusions from it. So this is another way that we can represent data. So the next one here then is what are known as Sankey diagrams. So these are examples of these particular types of diagrams. In this, so what are we looking at? So this one here on the left it's a diagram showing the energy transfer for a filament bulb. So if you think just a normal bulb that has a filament in it, so this looks at the energy that goes through it and what way that energy is used up. So energy is measured in joules. So we have this unit that it's measured in, and we can see that for the 100 joules of electrical energy that's going into this bulb, only 10 joules are being actually used to produce light. And the rest of the energy, so 90 joules, nearly like 90% of the electrical energy is just being converted into heat energy, and it's being wasted. So the majority of the energy that's been generated that goes through this bulb, so the purpose of a bulb is to make light. So we can see that only 10 joules of, only like 10% of the energy that goes through the bulb is actually producing light. The rest of it is making it really hot, and it's just being wasted as heat energy. So if we compare that then to, so what this does is it shows the energy transfer for an energy saving bulb. So these are the more modern kind of bulbs. And we can see that, so for the 100, so if we take the same amount of electrical energy, 100 joules is going in. So we can see that 75 joules has been used to generate light. Okay, so we have a lot of light being produced. That's the purpose of a light bulb. That's what we want. Whereas a lot less is being turned into heat. So like, nearly 25%, if you like, of the electrical energy is being converted into heat, and that heat just goes into the room, and it's if you like, this is kind of like a waste. It's like waste energy that's not being used to generate light. So this here represents energy saving bulbs, and then this here represents filament bulbs. So we can see that, like, so what are the patterns? Well, we can see that these filament bulbs, they actually waste an awful lot of electrical energy. The energy is just being converted into heat. Whereas these energy saving bulbs, we can see that a lot of the electrical energy is being converted into light, and that's good. So we can see that in relation to using electricity, the energy saving bulbs are much more efficient than the old filament bulbs. There's not really any kind of anomalies that we can notice here from this. What are some of the justifications or conclusions that we can come up with? Well, we can see from this data set, we can see that energy saving bulbs are far more efficient in relation to energy use than filament bulbs. So these are Sankey diagrams, and again, it's another way that you can take data and present data. And then just the last thing that I want to look at in relation to this section, so we have what are known as patterns and relationships in data. So there's different types of patterns that you kind of come across particularly when you create these types of diagrams here. So interpreting data involves looking at data and saying what patterns that you can actually see. So some of the patterns that you can see. So if we have a look at this one here, so this is a jogger's position versus time. So as time goes by, time in seconds, the jogger's position changes. Okay, so they go from standing to moving, for example, nearly, like, let's say 60 meters within 16 seconds. So this here is what's known as a linear relationship. So when we plot these two data points in relation to each other, we can see that we get this like straight line relationship. So this is like a pattern. So when it's like that, this is what's known that there's a correlation. So there's a relationship between time and position in relation to jogger's position versus time. So this is what's known as a positive relationship. So as time goes by, this the position in meters increases, and that makes sense. So as the jogger runs, as time goes by, jogger jogs for a longer time, the more distance they're going to actually travel as well. So we can see here that there's a positive relationship between these two data points or data sets. So it's what's known as a positive correlation or a linear correlation. Now, if we look at this one, we can see that we have a different pattern that's being generated. So this is time traveled and travel time and speed are inversely proportional. So what does that mean? So along the bottom here, we have speed in kilometers per hour, okay, and then we have the time that's been traveled as well. So as the speed in kilometers per hour increases, what's happening is the time traveled is decreasing. Okay, so time traveled in hours is actually getting smaller. So what does that mean? It means like if you travel the faster you travel, okay, the less amount of time it will take for you to get to your destination. So for example, we can see here that if we travel at 20 kilometers per hour, it takes roughly about 5 hours to get to the particular location, whatever this location is. Now, if we increase that to 60 kilometers per hour, the time traveled, or the time that we spend traveling, is actually going to dramatically reduce down to 2 hours. So again, so the faster you can travel, the less time you're going to be spend actually traveling a particular distance. So this is what's known as an inverse correlation. So for example, as it gets bigger along the bottom here, as the speed increases, this the amount of time it takes to get to the destination decreases. And these are what are known as an inverse correlation. So as one variable along the bottom gets bigger, the other variable along this other axis gets smaller. And then we can have something like this. So imagine if we measured two different variables in relation to each other and we plotted them on a graph like this, and we can see that they're all over the place. There's actually no correlation between this data set here and this variable here and this variable here. So this is what's known as there's no correlation between them. There's no relationship between them. So hopefully that makes sense, and we're going to be doing an assignment in relation to looking at different types of data and how the patterns that we can look at and the relationships between it. So if we just go back, so basically what we looked at then is we looked at like how students should be able to produce and select data. So we looked at how we make data and how we can select data. We looked at like qualitative and quantitative types of data. We looked at how data can be analyzed to identify patterns and relationships. We looked at like what anomalies are. We looked at how data can be used to make observations and draw and justify conclusions as well. So that's data. That's kind of like an overview of what we mean by using data.